Welcome to Engineering Innovations, the official podcast of Purdue University's Elmore Family School of Electrical and Computer Engineering, where we explore the cutting-edge research and innovations shaping our future. I'm your host, Kristen Malavenda, the Communications Director for the school, and today we're diving into a fascinating area of technology that's making waves, flexible and stretchable electronics. And my guest today is Dr. Muhammad Hussain. He's a professor of ECE here at Purdue University, and his work is transforming the way we think about electronics, taking them from the rigid circuits that we know to materials that can bend, stretch, and even conform to our bodies. We'll be discussing how his research is paving the way for a new era of smart, wearable technologies and much more. Muhammad, thanks so much for joining me today.
Thanks for having me, Christine.
So let's start with, before we get into your research, what was your path to becoming an engineer?
I think if I were not institutionally trained, I would still have been ended up as an engineer, because I essentially keep asking myself about two things, like why and why not. And these two questions that actually drive me to my philosophy in my life, and which is why I do what I do. And that naturally ends up being an engineer.
Gotcha. That makes sense. Well, how did you end up in electrical computer engineering and this particular area of research?
That's an interesting, the history, because I wanted to be an astronaut.
Okay.
And at some point I realized that my chances were diminishing. So what happened is I was born in Bangladesh. I did my bachelor's there, and then I came to USC Los Angeles for my master's back in 2001, and I joined spring semester. So one Friday afternoon, April, I was in front of a small lab with the window door. When I looked through, I figured out that there are students who are wearing bunny suits carrying the wafer. And it fascinated me. I started asking around, and I realized that it's actually a course offered by my department there in electrical engineering. And I decided to take the register for that course, and that course was on semiconductor fabrication.
Okay.
And that bunny suit actually, that I wore, that made me so happy, because it's I was an astronaut.
Right.
And then I kind of never gave up on that bunny suit.
Just not taking it to the moon.
But what we make, that actually goes to the moon and will go to the Mars and beyond.
Excellent. So now that we're on to it, can you give a brief overview of your research and also just what sparked your interest in flexible and stretchable electronics?
So essentially, when I was doing my PhD, because of that bunny suit, my love for fab work, I spent a record amount of 10,000 hours in 3 years,
Wow.
which actually equates to 10 hours every day inside the clean room. So I kind of was a fab rat, and still something like that. So I used to make electronics, and at that point we went through I was very fortunate, because we went through the major transition for the semiconductor industry, as per Gordon Moore, who was the co-founder of Intel.
Okay.
So what happened is we were actually looking to for solutions which we can make our transistors, our tiny devices, in a completely different way. So I got involved in that, and I continued that. I joined TI, and I continued as a program manager of Sematech. So at that point, we used to make, and as of today, all the electronics, as you can see, they are kind of rigid.
Yes.
Okay. But I could feel that when you look at the nature, we get our inspiration from nature. Nature has many things which are rigid, rock, right?
Mm-hmm.
But you won't find so easily a flat surface, right? So these are actually very good for flat surface. So if there is a way that we can make them flexible, like paper,
Mm-hmm.
right? Then that would be great.
Right.
And there was already work going on, and is still continuing, material based, which are naturally flexible and stretchable. But the challenge is that stopped being the flexible hybrid electrodes, means that they still continue to use these rigid, the packaged
Yeah, like
circuitries.
the traditional chip that we think about.
Yes. with some of the flexible components.
Okay.
I actually decided, no, we can go beyond that and make everything flexible. So, like including this, right? And without compromising on the performance, energy efficiency, integration density, everything. And that actually brought me here to pursue this kind of research.
So, for people who are listening who aren't familiar with this, like what are some of the potential applications of your research that we would, everyday person would know about?
So there are two things. One is the curiosity driven, so which actually we would like to have more intimate interfacing with nature so that we can understand what's going on. That takes it to the level of wearable is one examples, but definitely implantable also, right? As an example is like, the as a personal, like, that someone can have kidney stone, recurring event. And you know how painful it can be. But if there is a way that we actually could get an early indication and we can take measure on that's a fantastic thing, right? Like, so that's just an example of that. You go to like, as you know that our oceans or like, the marine environments are getting polluted, and that's actually harmful for our marine species and the marine resources. So we tagged them, it's called bluefin, and back in 2020, the world's largest consumer electronics show in Las Vegas, CES, we were actually awarded the Best Innovation Award. That's as of today, the only academic group.
Nice.
Right, like, so I think the possibilities are immense.
So, looking at the next 5 to 10 years, and even beyond, what is the next big step, and how are you going to get there?
I think one of the things is like, that we also need to know about the fundamentals. So what's going on in the industry, and I always love to keep it up with that one because I was trained in the industry, and like, when I joined Purdue 2 years back, like, I immediately restarted the course which was in hiatus for 7 years, like, on semiconductor fabrication. So the industry is moving toward like, the vertical stacking, which we started many years back as a research group. And like, so what we are doing is like, that actually enables us to bring like, the heterogeneous material sets. So it's a part of the heterogeneous integration. So the question is that how we can actually translate that also in flexible and stretchable and shape reconfigurable format. Okay. And today, as we say, that still that flexible hybrid electronics is actually using those rigid chips. Instead of that, if we can actually get to the point where all our electronic components are completely flexible or those kind of things, like, that's going to be fantastic. But it is a very hard, steep, like, the path.
Yeah. What's the challenges of going from a hard traditional chip to a flexible one?
Mechanical reliability, and while retaining all the electrical and optical and magnetic and properties, and then try to get closer to the biological properties.
Gotcha. So when you're in the lab working on this stuff, I know you have students that work with you. First of all, what qualities do you look for in a student that you say this person's going to be a good engineer and good for my research?
Passion.
Okay.
And I think like, that I do believe as an educator, and I actually take my education side like, as a way to essentially every single of my classroom or course, I find it as an opportunity to enrich mutually, because I consider that as a platform to share our experiences, our backgrounds, and our the interests. So what happens is like, because you see that when a student comes, I came here from Berkeley. A student, when they are admitted in Berkeley or Purdue or like, UT Austin, where I did my PhD, or USC, pretty much like, and many other schools, maybe I'm not like, giving the laundry list. But the point is like, that they have already proven themselves.
Right.
All I need to know about where they're going to excel, and people are going to always excel when they can chase their own passion. So I, just as an observer, like, I keep looking at like, where my students are doing. When someone is very good with testing, someone is very good in hands work in fabrication, someone is very good with programming. So I try to basically like, encourage them and bring the projects to them and mold it in a way so that they can excel. And, I keep saying, you give your heart, and like, we are going to make it happen.
Yeah. So a lot of times I especially notice with our engineering students, they get very frustrated if they hit a roadblock. And how do you teach your students how to navigate around challenges?
Because I always tell them that two things. One is that how we define efficiency and productivity. So I say that every second, our world around us, presents us with a situation. Okay, and how quickly we understand what is required from us, or how we can actually break the barrier, that's efficiency. And how quickly we reach there is productivity. That depends on resources and so on and so forth. But when we understand that part, right, and I tell them there's nothing called silver bullet. If you fail today, that means that someone will one day may overcome, or people will know that this is not the right path.
Right, so you're learning something even when it doesn't work out.
Exactly. So I keep inspiring them, that, and I always I even go to to the fab or places that. So when they get tired, right, they have at least a shoulder to lean on. So I think that human aspect of so that completely diminishes that barrier between the faculty students. It's rather they're going to be my colleague.
Right.
Just soon enough.
Yeah.
They will be the university president. They will be one day the leaders, industry thought leaders, right? So there is no way I can actually just neglect them or just denigrate them.
I think it goes along against some of the stereotypes of engineers too, where people think it's very cut and dry, and some people don't understand how exciting it is. And the view of an engineer is someone who can't interact socially.
I think that then actually that leads us to a point is that we get Doctor of Philosophy in many of these schools. Of course, MIT gives Doctor of Science, and some other schools are coming forward. The question is that I keep asking many people, and then just give them a shockwave. I say that that you did your PhD in an engineering topic, but why you are getting a degree which is called Doctor of Philosophy? What is your philosophy? There are many people actually as if what is he asking? I think the question is there, right? That our job as academics is essentially to pursue that enigmatic stuffs. We pursue things which is going to be the potentially make a change, that elevate our quality of our life. And then we, in an unbiased manner, we present it to the society, and they are going to make a choice,
Gotcha.
right? So, and that aspect is also that when we think about as an educator, it's our job is also as an engineer to simplify complex things. When we basically say that, no, this is for my Friday afternoon, my small group of peers, I think we get lost. And I always, if I have an idea, there was a time 10 years back I used to actually talk to my mom and my daughters.
Oh, okay.
Because the daughters, they were under 10, and my mom, she became just 70 plus. So if they could understand in a minute of my discussion what I'm trying to do, I know that it's going to be something useful.
Absolutely. That's a great way to go about it. We mentioned a little bit earlier, touched on semiconductors, and another thing that you do is you do some important work in helping students develop tech skills. So I'm really talking about the Purdue Summer Training Awareness and Readiness for Semiconductors program. It's called STARS. So tell me about that program and the need for the effort.
Yeah, so as you know, that USA as a country, our country, we actually, contribute in the global ecosystem of electronics and associated computing, internet, and everything, more than 85%. But unfortunately, from the physical hardware perspective, we only produce 12%. Okay? So that means that increasingly we are not capable of making anything on our own. So I throw a challenge, and that challenge is, in the next 5 years, can we make an iPhone or similar device, everything in USA?
Okay.
Or can we make a Tesla or a similar car or that kind of vehicle, right, that in 10 years from today in the USA? Right?
Be self-reliant.
And other countries can do the same. It's not, there is no, and we can have our allies, we can have competition, it's fine. The point is that we need to have those kind of skills. It's like, today, every single student that comes to a campus for their college education, they know a programming language.
Right.
But we do use the electronics, we just don't know what it is. So when I came here immediately, I started the looking around, and this is not something the first time. I've done it in Berkeley, I've done it in KAUST and other places. So what we did, we immediately we started the graduate course today. This semester, just to let you know, we have 90 students. We can't take any more, right?
Okay.
So that's one. Second, we started I said that there are 4 E's, so which is essentially engage, excite, empower, and enrich our students. So we started a seminar course which is called Chips Changing the World, and which actually for the beginning year students, they come and we start inviting the industry folks to give 4 answers. What is your premium semiconducting product? What is the role of semiconductor there? How is your upbringing within the semiconductor ecosystem? And what is your take-home message for these students, right? And guess what? In the first year when we did that, back in 2023 spring, after the course ended, 85% of the students, they decided and they said, we would like to pursue or we would like to know more about semiconductor. So we were upfront. So I said that not only we offered the course, back in 2022, fall semester when I came, I said that we need to actually empower them, right? Okay, so let's offer a summer program, right? It was just oh no. I said no, we have to do it. Yes, let's do it. And I'm pretty good with coming up with names because I love naming things. So it starts came from there. And Professor Lansdowne, he and I actually said we have to go. We are going to go. We are boiler makers. I would say, by the way, let's change our name to chip makers.
Okay, there you go.
So we launched that program, and the industry came forward, and we basically trained the 72 students. Okay, manufacturing and design track. Guess what happened? Every single one of them, they got summer internship. So we basically pulled it forward. Yep. They didn't need to wait, right?
Right.
And then I launched the Victors program, the Veterans Inclusion and Competency Towards Semiconductors, bringing the local veterans. We designed the course and we did the workshop for the high schooler students, 6 counties. Intel came forward. We launched the course Semiconductor Manufacturing 101, which today in 10 months has 10,000 learners globally. Synopsys has came forward, so we are going to actually do a new course on Semiconductor Design 101, and we are designing now the mobile fab for my last 18 months Stealth project. So this fab will go an 18-wheeler from rural town to town, city to city, and we are taking fab to the kitchen room.
Nice. It sounds exciting. See, the way that you describe it, if I was in your class too, I would get excited about it because your excitement is contagious. For anybody who maybe, doesn't know the word semiconductor or doesn't know the importance of semiconductors, can you explain that?
Yeah, very simple. Okay, so, that we are very familiar with electricity, right? So wires are bringing electricity to us. So any material that actually help to conduct electricity, that's conductor. Okay. The one that restricts that kind of movement, that's insulator, like a rubber sole, the shoes. And in between there is semiconductor, where it will conduct and it may not conduct. But we do have a way so that we can actually manage that.
Okay.
And that makes it semiconductor. And silicon today is the best semiconductor material that we know. Not because it's best, but it is an optimal solution. In engineering, we always work with optimal solution.
And so are people trying to develop even better things than silicon?
Well, that kind of pursuit will always go. That in science, I always say that there is nothing absolute truth in science. What it means is today with the existing resources, both the physical, the human brain, our knowledge, what we explain today, 100 years from today, it might be completely different way explanation. Today's explanation is not wrong. It's just an evolving the condition.
Right.
So there will always be pursuit of new materials, but I would say one thing, though, that in engineering, if we have something which has 5 advantages and 2 disadvantages, we must have to make sure that these 5 advantages are always met,
Okay.
neck to neck.
Mm-hmm.
Then either we are having the one of these advantages going away, or both, or ideally going away both, and these 5 become 7 advantages.
Okay.
But if we can't meet these 5 advantages, then it's a cool science. But to be an engineered solution, that's a long, arduous path.
Right. We talk a lot about energy efficiency when we talk about these things too. What's the importance of energy efficiency?
I think the increasingly the way that the number of electronics, the computing, the data, that's the usage that's increasing. So that's actually comes with these hardwares. They need to be part of. Okay. And that's why the energy efficiency is very important, because who is going to supply the energy? If you look at the solar cells, these are great renewable energy, but it has certain challenges. Can we make a solar cell which will be the lighting us up when it's dark? Nope, not yet.
Right.
Okay, how can we take them through the grid system? The reason that fossil fuel are so popular, because in a bottle of Coke, in a Coke bottle, we can take some the fossil fuel, and it has the highest energy content, right? Maybe it's not competing with nuclear, but that's not something we are carrying.
Right.
So the question is that we want things to be energy efficient. 2 ways. 1, increase the supply, but that means that our battery needs to be the making with its volumetric today, it's too heavy, too big.
Mm-hmm.
So we have to basically challenge and change the status quo, and we have to reduce the energy consumption. And that's where we need to get an inspiration, nature. So we consume only 20 watts, and think about how how our brain can think.
Yeah. Well, also a big part of this, I imagine, is interdisciplinary research.
Yes.
How important is that, and what are the areas or the fields of study that you're most likely to work with on these problems?
I would always say that everything that I learned during my middle school and high school, I find them they are the most handy. Math, physics, chemistry, biology.
Yeah.
Okay, that's number 1. But I think their evolution, their advanced level, is any kind of fundamental science. When we look at the physics, chemistry, or we look at the material science, they're all important. Chemical engineering is very important for processes. Computer science is very important for data analysis. That electrical engineering is very important for designing the devices. Mechanical engineering is very important for our the equipment sets. Civil engineering is very important to make things sustainable,
Mm-hmm.
right? So I offer a course for just the beginning year students. It's called Engineering Innovates, right?
Okay.
And every day, so I just teach this course for 5 weeks, 3 days, 15 classes, 12 classes. I introduce 12 engineering disciplines with what happened in the past and what is the next big marvel.
Okay.
Okay, so that actually helps them, to eventually to get interested about a new, okay, I want to check out nuclear engineering. I want to
Right.
check out the aeronautical engineering. I'm not an aeronautical engineer. I wanted to be an astronaut. But I think that point, I just would like to bring it to them.
Mm-hmm. Yeah, absolutely. So you obviously spend a lot of time on your research because you love it, but there are times maybe where you need a break. What kind of things do you do in your free time to recharge or just have fun?
2 things I do. Every year I have an objective that it's a bigger objective, and the other one is my daily ritual. So I'm pretty decent cook. Okay, I do a lot of gardening. I sleep. I spend a lot of time on streaming media,
Mm-hmm.
And in the online social media, no matter whatever people say. Obviously, when I'm in the driving, I have music.
Yep.
I watch occasionally the movies, right? And I maintain, a really good and continuous, sustained relationship with my families, friends. There is not a single day I didn't talk to my mom.
Oh, nice.
Since I left home back in 31st December.
Wow.
Or the many of my friends, colleagues, I keep relationship. But there's a bigger objective that I do. What it means is that this year, Bangladesh, where I was born, has gone through a major change. Our youth, they have come forward. We went through a political uprising, which was very important for our country. We came out of fascism, so period. But the question is that we would like to see it rebuilt. So how we can essentially help, right? Like,
Right.
the technological innovation, all these kids, that they do robotics and so on and so forth. So I actually engage with them and organize competition, the write to them, talk to them,
Yep.
to basically nurture them. Next year, I will do something else.
That's really interesting that you kind of approach everything in your life from an engineering perspective, and you're engineering your goals, basically. So I know one other thing you do is you have a podcast of your own. So tell everybody about what that podcast is and what you do on it.
Okay, so what happened is during the time of pandemic, I was in Berkeley, 2020, and the nature became so beautiful and everything because we were not outside, right? Okay, so at that point I was just thinking that many of our the legendary figures in electron devices, they were retiring. But we do know about, we have seen them as, giving talks, again, cut and dry, right?
Right.
Okay. So I actually thought, that we would like to know about these people, as a human.
Right.
Okay. So I just came to my mind, and this is who I am all the time from my childhood. I actually put together I kind of know about, what people might be looking for. I'm very much involved with the Electron Devices Society, IEEEs. So their board of governors, that was a virtual conference, that I presented that.
Okay.
I'm very fortunate, they said, oh yeah, go ahead. Do you have the questions? I said, yeah, I do have the questions. I would like you to volunteer the questions, then I will show mine. And it matched,
Right.
They're empowered. So then we launched, and we have a list. And Professor Chin-Ming Hu, who can be considered as the father of modern semiconductor devices, of UC Berkeley. So he said, yeah, I will do it. Professor Lundstrom did it, right? The NanoHub is kind of his brainchild. So many of, as of today, we have done 29.
Oh, wow.
My nexts are going to be, I have done with Professor Sharful Alam. I will be doing for Shupriya. And Saif Salahuddin, who was Shupriya's student, but now he is in Berkeley and a very famous professor. So, I do have a plan for them. Kaushik Roy,
Yeah.
right?
Yeah. Oh, there's so many people just in Purdue ECE.
Exactly.
You could have endless podcast episodes about it. Well, thank you so much for joining me today and talking about semiconductors and flexible electronics. I really appreciate it.
Thank you so much.
I hope you've enjoyed learning about the fascinating world of flexible and stretchable electronics and semiconductors with Dr. Mohammed Hussain from Purdue University. It's really incredible to think about how this technology could soon be integrated into our daily lives, from health monitoring wearables to smart clothing, even beyond that. Thanks so much again for listening. If you found this conversation as interesting as I did, be sure to subscribe, leave us a review, and share this episode with others who might be interested in the future of technology. And to stay updated on upcoming episodes and to explore more about Purdue ECE, you can visit our website at purdue.edu/ECE. You can follow us on all the socials, Facebook, X, Instagram, LinkedIn. You can check the show notes for links and more information about that. And we'll be back in another month with a new episode.